My friend asked me to help him round up his 37 sheep. I said 40.
Okay, we're going to get started here. Our next lesson is on word problems. So we're going to use complete the square, which is CTS, and or quadratic formula, which is QF, to solve problems and continue to develop problem-solving skills. This is only word problems. This should still be a review for most of you from grade 10 academic. However, if it was a long time ago or if it was online, I'm going to try to be as thorough as possible for those of you that might be for more or less learning it for the first time. The first thing I'm going to do is kind of build a mind map or a roadmap of what your thought process should be for these questions. And then you can use this for when you're deciding what to do on your test or in the homework questions. So let's start with some key words. If you see something like the question asking you for a max or a min, or maybe it says best, or maybe it says optimal. So if you see any of that, your mind should go to the vertex. And once you think vertex, you got to be thinking vertex form. And how do you get to vertex form? Complete the square. If you see something like 0, ground level, or it's asking you for a specific value, your mind should go to solving, which is going to mean finding the zeros, which means one of two things. Factor if it's easily factorable. If not, or if you don't even realize how to factor it, maybe the numbers are too high for you, then quadratic formula will always work. So those are that's kind of your mind map. Those are your two big thought processes. Is it asking you for a max, min, best, optimal value? Vertex, complete the square. If it's asking you for 0, it says something like ground level. It asks you for a specific value. You're solving for that value. Set it equal to 0, factor, quadratic formula. And we're just going to work through a bunch of examples now. Our first example, the cost to run an assembly line per hour is given by C equals blah, blah, blah. C is the cost per hour to the company in thousands, and X is the production level in thousands of units per hour. What production level will be best for the company? So I see the word best, which probably means we should complete the square. So vertex, complete the square. And if you need to make a little visual, due to this a value being positive, this is a parabola that opens up. And if we're talking about cost to the company, obviously what's best for them is minimize. So really this is asking you for the minimum, or at least where does the minimum occur. So this boils down to your ability to complete the square. C equals, the first thing you should do is common factor out that a value out of just the first two terms. So you will get x squared minus 4x. Now we've already done, we've already done complete the square in a previous unit or lesson. I wasn't going to show you all the steps, but maybe I just will. So at this step, remember, the key is half your b value and square it. So I'll just make a little note here. Half of that is -2 squared is 4. So +4 -4, and then we still have that +2 on the back end. Then 0.28, x squared minus 4x plus 4. You got to bring that -4 outside the brackets, right? So this has got to move out. But when you do, don't forget to multiply by the 0.28. You don't have to show those steps. I'm just showing you for the sake of the lesson. So that will give you -1.12 plus 2. Then to finish this off, you just have to factor this. It's always going to be x, whatever that first sign is, minus whatever your half value was, which was -2. So x minus 2 squared plus 0.88. Sorry, the pen scribbled there a bit. Clean that up. 0.88. So now that you're there, you kind of have to be able to pull out the information. So if we look back at the question, it says X is the production level in thousands of units per hour. So X gives you, so in this case, X equals 2 is the units per hour, but in thousands. So we got to multiply that by 1,000, which gives us 2,000 units per hour. C, which is the Y value of our vertex, our optimal value, which in this case is a minimum. So that's our cost per hour, which is 0.88, right? But that also said in thousands, so multiply by 1,000 gives us $880. So what production level will be best for the company? We need a therefore statement for word problems. Therefore, producing 2,000 units per hour would be best. I'm just going to write in brackets, it would minimize the cost. So if we were to kind of add to our little picture here, let's just say there's an X and a Y. Our vertex, that was 2,000, and our cost was 880. Same question, part B. What production level will result in a cost of $10 per hour? This is asking you for a specific value. Therefore, you should be thinking I have to solve, which might mean quadratic formula. We do have an intermediate step to do here. And remember, the cost was in thousands. So if it's saying $10 an hour, we have to take 10 and we got to divide by 1,000 because using our equation it said in thousands, which is 0.01. So let's start out with our equation. C equals 0.28x squared minus 1.2x plus 2. It gave us the cost, which is C, so we're going to replace C with 0.01. And you want to set that equal to 0. Remember, when you solve, that really means set it equal to 0 for a quadratic. So 0 equals, bring that over, becomes minus 0.28x squared minus 1.2x. I'm going to skip a step here. 2 minus 0.01 is 1.99. That does not look easily factorable to me. So we're going to do the quadratic formula. That's your A, that's your B, that's your C. I'm not going to bother writing the formula. I'm assuming everyone knows it. If you don't know it, obviously you can look it up because it's right in front of you from a previous note. So negative B, and since it's negative already, 2 negatives make a positive, 1.12 plus or minus negative 1.2 squared minus 4 times that times C. That's all square rooted, all over 2 times 0.28. That is just calculator work. So if you want to, take a moment, type that in your calculator, pause it, come back. If you paused, welcome back. You should have got negative 0.97. And that's problematic. We know that our radicand underneath the square root needs to be bigger than 0 or equal to 0. That is negative, and we cannot square root a negative. So that means no real solutions, which to solve or to provide a conclusion to our question, what production level will result in the cost of $1 an hour? None. It's not possible. So therefore, it is not possible for the company to achieve $10 per hour in cost. If we think back to our answer to A, the minimum cost was $880. So that this math just backs that up. Anything less than 880 is not possible. If you look at your parabola, nothing is lower than 880 of that quick sketch we made. Now, if this was a test question, if you realize that and you wrote that, that's good. I still, though, would want to see this work to prove that you know that, because if you happen to make a mistake with part A, then this question may or may not change. And it's always a good idea to continue to get practice with the process, which in this case is quadratic formula. Example number 2, a cliff diver's height is given by h blah, blah, blah. H is the height in meters, T is the time. Get rid of that T there. We're gonna get rid of that. You're gonna notice some of these questions look a little bit different, and even in your homework, just due to the quadmester and timing, I changed the order of some things, and we haven't done functions yet. That's coming the next time we're together. So that thing that you see H bracket, T bracket, you're gonna see that in other places. Just ignore that for now. That's function notation. Anyways, H is the height in meters, T is the time in seconds. When will the diver hit the water? So again, it's often a good idea to make a sketch. So we got height, we got water. I know my y-intercept is 17. That's just going back to grade 10. That's your last value in standard form. So we know that the diver, maybe they jump up, maybe they go right off, who knows. So when they hit the water, that's right there. That is a 0, which means we are looking for the zeros. How do I get the zeros? Quadratic formula. So that means the height is 0, right? Because that's height, and that's time. That's height. So we're looking for our zeros when it hits the water. So started with this, 0 equals negative 4.9t squared plus 1.5t plus 17. That's your A, that's your B, that's your C. Now, even if you didn't last time, I am going to ask you this time, pause the video, put those through the quadratic formula, and come back with your answers. And since we're being asked for time, I'm just going to say round all answers to 1 decimal place if necessary. So again, pause it, run that through the quadratic formula, and then come back when you're done. Welcome back. Hopefully when you did this, you got t equals 2 and t equals negative 1.7. Raise your hand if you got that. Awesome. Great work. Give yourself a high five. Now to answer our question, T stands for time, and we have 2 answers. Obviously that's 2 seconds. And if we were to continue this parabola this way, that would be negative 1.7. Now going to the left along our x-axis would be like going back in time, which clearly is not possible. So this is not a solution. Cannot have negative time. So what that does mean is, therefore, the diver hits the water after, and time was in seconds, after 2 seconds. Hopefully that makes sense. Moving on. Same question, but part B. When will the diver be 5 meters above the water? So this is asking you for a specific value. Which again means solve, which means zeros, which probably means quadratic formula. So they're giving you the height. So you're going to replace h with 5. So 5 equals negative 4.9t squared plus 1.5t plus 17. Bring that over, becomes negative 5. Skipping a step here, 17 minus 5 is obviously 12. Again, you see 0. That does not look easily factorable. Quadratic formula. There's your A, there's your B, there's your C. Again, just to practice, pause the video, try this on your own, come back when you're done. Welcome back. Hopefully you got, and again, 1 decimal place, even though I forgot to say it before you paused. Hopefully you got t equals 1.7 and t equals negative 1.4. Again, this is not a solution. Can't have negative time. So that means it's 5 meters above the water at 1.7 seconds. And just based off our little sketch before, that makes sense because if it hits the water at 2 seconds, slightly before that, 1.7 seconds, it should be above the water. That's kind of a little built-in self-check. Therefore, the diver is 5 meters above the water at 1.7 seconds. Approximately, because we rounded. C, when will the diver be at their max height, and what is the max height? So there's our keywords, which tells us vertex, which tells us complete the square. So H equals, and you're going to have decimals here, which is okay. You're going to have to do some calculator work. Factor out the negative 4.9 from the first two. T squared minus 0.31t. Half it and square it. We'll say, we're out of room there actually, so I'm just going to do this. Over little steps, divide it by 2, and take that number and square it. Half that, square it, you should get plus 0.024, then minus that, and then plus 17. Bring this out, multiply that by negative 4.9, gives you this. Plus 0.12 when you multiply by the negative 4.9 plus 17. And we are ready. This is going to be t minus the half value, which was 0.16 roughly, squared plus 17.12. So if we go back to our little picture, that was 17. So they got a little bit of height off of that and went down to the water. So we're looking for that. This gives us the time, which is 0.16 seconds. And that gives you your height, which in this case was the max, 17.12, I think it was meters. So if we add that information, and that's 17.12. So when will the diver be at their max height? 0.16 seconds. What is the max height? 17.12 meters. I'm just going to write therefore ... Therefore that, and therefore that. And you guys can clean that up if it was a test question. Make it a bit more formal. Our last example for the word problems. I like this type of question, so I'm going to put a star beside it. A room is designed to be 8 feet by 10 feet. If the homeowner wants to increase the area of the room by 100 feet squared by extending 2 walls by the same amount, how much wider should the extension be? Let's draw a picture. So I'm going to draw a big rectangle to start. Ignore that little extra little dip there. Actually, maybe I'll erase that, clean that up a bit. That's better. And we'll say that's the existing room. So that's 10 feet. That's 8 feet. Obviously, just from there to there and there to there. They want to extend the two walls by the same amount, but we don't know what that amount is. And if we don't know what something is, let's call it x. So they want to extend this wall by x and extend that wall by x. Well, that changes our overall dimensions now. So now we have this whole thing is 10 plus x, and this whole thing is not 8, not 80, 8. Okay, so far so good. And we know that we want the area of the room, the whole thing, to be 100 feet squared. Well, that's a rectangle. And how do you find area of a rectangle in general? Length times width. Doesn't matter what you call length, what you call width. So let's just say length is the 10 plus x side. The width is going to be 8 plus x side. And we know what the whole area is supposed to be. The whole area is supposed to be 100 feet squared. That is a specific value. Set it equal to 0, so on and so forth. So bring that over, it becomes negative. While we're at it, let's FOIL this. So that'll be 80 plus 10x plus 8x plus x squared minus 100. Collect like terms. X squared plus 18x, and then minus 20. I see 0. That means I gotta find my zeros, which means you could factor. That doesn't factor nicely, so that's quadratic formula. And there's your A, there's your B, there's your C. Take a moment, pause, go back to the quadratic formula, come back, round to 1 decimal place. Welcome back. Hopefully you got 1.1 feet and negative 19.1. To make sense of that, x stands for feet, a dimension, and obviously you can't have a negative amount of feet, so this is not a solution. So that means that if the homeowner extended each wall by 1.1 feet, they would achieve their 100 feet squared room. How could you double check your answer? Well, you could add 1.1 to each of those dimensions. So if we did 8, so 8 plus 1.1 is 9.1 times 10 plus 1.1 is 11.1. Now, since we rounded, we got a little bit above 100, we got 101, but that's just due to rounding. So that's how you could double check your answer. So therefore, they could extend each wall by 1.1 feet. There is your seat work. And there's also some review questions for you to work on. If you're wondering what the stars mean, the stars just mean challenge questions, and the more stars, the more challenging it is. We saw some word problems in a previous lesson. You've now had another full lesson on word problems. So yeah, this unit is more or less a review of your grade 10 quadratic unit. And just you basically have to have two processes down pat. Factoring / quadratic formula, mainly quadratic formula, and completing the square. Once you have those down pat, it's just a matter of pulling out the information. So your next lesson is your last lesson for this shortened unit, and it's just coming up with equations from information or from a graph. So if you want to get ahead of the game, you could review that lesson tonight. So then you have the entire morning tomorrow to prepare for your test. The lesson's really not that long, so you could also just do it in the morning like it has it in the schedule. Have a good day and talk to you next lesson.